We'll start by drawing the circuit with our power supply here, that's 9 volts. We have our first resistor here, then there's a switch before we get the second resistor here. So R1 is 65 ohms and R2 equals 96 ohms. We need to find the current through R1, firstly with the switch open and secondly with the switch closed. So let's have a look at with the switch open. So now just a simple circuit that only has one path. So the current is simply the voltage over R1. So it is 9 over 65, and that is 0.138 amps. Now, when the switch is closed, I'm going to actually work out the resistances that these would have in parallel, but then I'll show you that in fact we don't need to do that. But let's start. We'll say that 1 over the equivalent resistance for the parallel combination is 1 over R1 plus 1 over R2, which equals 1 over 65 plus 1 over 96. That equals 0.0258. So that means that the parallel resistance is 38.8 ohms. So you can see that adding another resistor in parallel has created an equivalent resistance that actually is lower than either of them. So every time you open a new branch and give current another path to travel through, you lower the total resistance. So we could work out the new current. Let's say we want the total current coming out of the power supply now. That's just going to be the 9 volts over that equivalent resistance. So now the total current has gone up to 0.232 amps. But to work out what proportion of it is going through R1, we apply Ohm's law directly to R1. So we know that the voltage across it is just the same as the voltage across the resistor, the power supply, and also the voltage across this resistor. So we still have that the voltage, which is 9 volts, equals the current through R1 times R1. So we still have that the current through R1 is the same 0.138 amps. And so that just reminds us that it doesn't matter how many other branches open up. The current through each branch is independent.